Hello, brothers and sisters in all over the world. I'm zedikas Electro. As usual, today I'm in front of you to tell you about some important features and characteristics about MCCB. So MCCB is nothing, which is a molded kit circuit breaker. So this circuit breaker is one kind of an electrical and electronics device. So they are selected by the current rating. So in a current rating, we can use these things especially for our systems in order to control those our systems from damage or some problems are faced upon here. The damage of the systems will appear because of many factors, because of power fluctuation. So what does mean it by power fluctuation? So power fluctuation is nothing but it is a voltage drop, upgrade, and under voltage and above voltage. So here such kind of problem will face in our system when for environmental applications or industrial application or in our home appearance, because nowadays, as you know, that every our systems we use it in our home application and as well as in industrial applications are the product of some kind of electrical motors. Electrical motors are controlled safely by those electronic devices such as fuses, like breakers. Breakers may be a molecular circuit breaker or a miniature circuit breaker. So a molecular circuit breaker are basically for three-phase power system, and this miniature circuit breaker is basically used for single phase power system. So my motive in here is to show you about how we can select the right MCCB for our system. So when we cannot select the right MCCB for our system is under danger. So it may fail or it may damage or it may burn. So in order to save our system sufficiently, just we have to select the right design of the right design of this MCCB or miniature circuit breaker. So other things are integrated with these particular devices such as fuses, what I say, because it's not mechanically but it's electrically. We have integrated those things for our system before the power is come into our system. So to do that, we have to select this miniature circuit breaker. So the miniature circuit breakers are they are integrated in such a way here. So by the way, it's a very simple and minor thing, but in a physical world it have a very versatile advantage. So which is physically seen in such a way that the line is like one line, two line, three, which means it may be three phase or it may be a single phase. But as we can see, the physical components of this device is in such a way as a very simple and minor, but the advantage in certain industries or the advantage in certain home applicable machineries, it's very important. So I know their advantage because of my experience when I faced it with some related problem with deal of these things here. So in my industry, when I was working as an electromechanical engineering in a certain industry, but every huge components are controlled not manually by those things. So in order to automate those systems, we cannot use it like so much sophisticated controlling devices while we learn it in a control engineering specialization and a both of undergraduate and postgraduate courses. But the main devices those control our system safe from damage or of damage or from over and under voltage and makes our system safe is what I call it these MCCBs, timers, contactors, and relays, which are basically very important to make our system safe. So there is in such a way, but the lines are integrated with those MCCB in such a way. So these are L1, L2, L3, and here are nothing, which is the power line. So the power line is, let's say, from the national grid by the help of a transformer, and it is coming into implemented into the breakers through the bus bar. So let's say these L1, L2, L3 are the lines which are coming from a step down or a step up transformer. So from that bus bar, those lines are linked or jointed in such a way. So and then which is the input power in this 4-volt MCCB. 4-volt is nothing, by the way. This line 1, line 2, line 3, and this is neutral 1, 2, 3, 4. That is why, because they put in here 4-volt MCCB, and here are the rating amperes of that system. So this is all about the introduction of this the physical components. Let's say the 3-pole and the 4-pole MCCB difference here is in a 3-pole. The lines are 3 here. Lines are 3, which we have one line 1, line 2, line 3. We have no neutral line in here, but in the case of 4-pole, we have line 1, line 2, line 3, and the neutral line. The black wire is connected, and this flat is here. So this is all about the physical configuration of this MCCB or multi-key circuit breaker. But after all, let me tell you about how to calculate the right MCCBs for our systems at home and at industrial application, at industry. So at industry. So in here, let's say my motor, which is gonna be around the system is, let's say, 5.5 kilowatt. So this is what we call it a power of our motor, power of my motor or our motor or motor here. So if that is so, we must select the right and the appropriate MCCB or MCB breaker for this device, particularly to control that. So by the way, there is a power 5.5 kilowatt, which is equivalent to, which is which is kilo is with 1,000, so which is 500, 5,500, 5,500 watt, which is again equivalent to, as you know, that in a certain power line there is the summation and the integration of current and voltage, so which is what equivalent to 5,500 volt ampere here, So my point in here is how we can select the right and the appropriate MCCB. So in order to select the right MCCB, in order to select that, just it's nothing, it's very simple. So let me tell you it in a very detailed manner. So our power is 5.5 kilowatts. So you have to get the motor breaker or the motor breaker, the motor breaker is a power. So the motor breaker current, which is for this 5.5 kilowatt. So 5.5 kilowatt is basically the power one. So to get the right ampere, so we have to multiply this 5.5 kilowatt multiplied by 2, which is equivalent to 2, which is